Your AI assistant needs to roll some dice. But how do you securely connect it to your custom Python functions without exposing your server to the public internet? We'll implement the complete client-side workflow, authenticating with OpenAI's Responses API, configuring the MCP tool connection, and making the secure request that ties it all together. You'll see exactly how the headers, server URL, and token work in practice.
From OpenAI, import OpenAI. Hash your server URL. Replace with your actual URL. URL equals https://yourserverurl.com. Hash your access token. Replace with your actual token. Access token equals your access token. Client equals OpenAI. Resp equals client responses create. Model equals GPT-4 Tools equals type MCP. Server label dice server. Server URL FURL/MCP/. Require approval never. Headers. Authorization fbearer access token. Input equals roll a few dice. Print resp output text.
This demonstrates the AI tool integration pattern, where custom backend functions become first-class citizens in an AI workflow. The code bridges Python logic with OpenAI's Responses API through FastMCP, creating a seamless connection between human language and executable tools. What makes this distinctive is the complete abstraction of transport and authentication details. Your tools remain pure Python while gaining AI accessibility. The pattern works by establishing a declarative contract between your server and the AI system. FastMCP exposes tools via a standardized interface that OpenAI discovers dynamically, while authentication headers ensure secure communication without exposing internal endpoints. This separation of concerns lets you focus on business logic, while the framework handles discovery, invocation, and result formatting. This approach solves the problem of AI system extensibility without vendor lock-in. You maintain full control over your tool's implementation and hosting, while the AI treats them as native capabilities. It's particularly valuable for adding proprietary logic to AI workflows, enabling scenarios like custom data processing, legacy system integration, or domain-specific operations that would be impractical to implement purely through prompt engineering. Let's break it down.
From OpenAI, import OpenAI.
This imports the OpenAI client class, the primary interface for interacting with OpenAI's API. It handles authentication, request formatting, and response parsing, abstracting the HTTP layer so you can focus on model interactions.
Hash your server URL. Replace with your actual URL. URL equals https://yourserverurl.com.
This defines the base URL for your MCP server endpoint. It's a placeholder that must be replaced with your actual server address before deployment, ensuring the client connects to the correct remote service.
Hash your access token. Replace with your actual token. Access token equals your access token.
This defines the authentication token for server access. The token authorizes requests to the MCP server, preventing unauthorized tool execution. Always replace this placeholder with your actual token in production.
Client equals OpenAI.
Instantiates the OpenAI client, the entry point for all API interactions. This single instance handles authentication, request routing, and response processing throughout the session.
Resp equals client responses create. Model equals GPT-4
This initiates an AI response using the GPT-4 model. The model parameter specifies which AI engine handles the request, determining capabilities like reasoning complexity and tool integration.
Print resp output text.
This outputs the AI's response text from the completed tool call. The output text property contains the final result after all tool executions, including the dice roll results from your MCP server. FastMCP tool integration. The OpenAI Responses API bridges AI models with custom tools through MCP servers, where your Python functions become first-class citizens in the model's toolkit. Headers carry authentication silently, while the tool schema travels openly. Never confuse the two layers. This pattern turns any Python function into an AI capability without rewriting the model's core logic.
The server that hides its address becomes the most visible tool in the model's mind.